What's happening, people? Pastic here. I'm going to talk a little bit about some properties of trigonometric ratios, of the trigonometric functions. So the first one I'm going to talk about here today is the complements theorem. So again, we're going to need to draw ourselves a pretty little right triangle, label our sides A, B, and C, little c, little a, little b. Isn't that beautiful? So now we're talking about the complements theorem. In order to talk about the complements theorem, you got to know what complementary angles are. It was a topic covered in geometry. So in geometry, you learn that complementary angles are any pair of angles, typically, that add up to 90 degrees. So if you get a look at this, angle C is 90 degrees. Well, what does that mean about angles B and A? That means angles B and A, if one is theta, the other one has to be whatever makes up the other rest of the 90 degrees, because this is 90 degrees right here, this is theta, and that's going to make this one 90 minus theta. It's going to be whatever's left over, because those two angles, A and B, have to add up to 90 degrees. So if I were to add 90 minus theta plus theta, just do that real quick. What's that give me? It gives me 90 degrees. Because the negative theta and the positive theta cancel out. So A and B are indeed complementary angles. So what's going to be true? Well, let's take the sine of A. Sine of A in this one is going to be A over C. Well, what about the cosine of B? That's going to be also A over C. And this is very general. I'm not actually using numbers for the most part. I'm just using a very general situation. So I'm basically proving or demonstrating that this is true. So what did I just show? I just showed that the sine of one complementary angle is equal to the cosine of its complement. Or I should say that a little better. The sine of an angle is equal to the cosine of its complement. And the cosine of an angle is equal to the sine of its complement. So how do we write that out in sort of like pre-calculus or calculus terms? Well, we're going to go like this. Instead of using B, we'll use theta. So we'll say the sine of theta is equal to the cosine of 90 minus theta. That is one part of the complements theorem. The other part of the complements theorem is kind of intuitive based on that. So you have the cosine of theta will equal the sine of its complement, which is 90 minus theta. So these two things right here are identities. They are basically saying the complements theorem, which is, again, the sine of one angle is equal to the cosine of its complement. That's it for now. Catch you all next time.